So hello guys, today we are going to solve a question that is largest subarray with zero sum. Largest subarray with zero sum. It is a Geeks for Geeks question, medium level question. Okay. So we will first start by reading the problem statement. What does the problem statement says? Okay. So you are given an array having both positive and negative integers. The task is to compute the length of the largest subarray with sum 0. The task is to compute the sum length of the largest subarray with sum 0. Basically, it is telling you, the question is telling you that you are given with some array. You are given with some array. You have to tell the largest subarray, largest subarray with zero sum, Okay, you have to return the length of the largest subarray. Length of the largest subarray with zero sum. Okay, first we will understand what is a subarray. What is a subarray? Basically, suppose in 1, 2, 3, subarray is just a continuous sequence in the array. Continuous sequence in the array. It can be of one element also. It can be of one element also. Okay, so the subarrays for 1 to 3 will be, if I start from the first position, the subarrays can be 1, the subarrays can be single 1, 1, 2, 1, 2, 3, 2, 2, 3, and then 3. Okay, so these are my subarrays. Which are not my subarrays are 1 and 3. Suppose I take 1 and 3, so these are not my, this cannot be my subarray. This cannot be my subarray. Also 2, 1 cannot be my subarray because it should be continuous. It should be continuous. Okay, so if this element is occurring later than first, so it should come at the second position only. Second position only means it should come later than 1 only in the subarray also. It cannot come before it. Okay, so if 2 is a part of my subarray, then all the subarrays can only start with 2, then 2, 3. So these are my subarrays that are starting with 2. Okay, so now we got the definition of what is a subarray. Okay, now if I give you the brute force approach, first basically I'll tell you what is the meaning of zero sum. How can zero sum array be existing? Okay, suppose if this is the subarray 5 minus 5, 2 minus 2, 1, 3, and then 4, 7. Okay, 4, 7. So if you try to compute the sum, of this subarray, this is a subarray starting at 5, ending at 1. Sorry, starting at 5 and ending at 2 minus 2. Okay, so this is my subarray, and this has a sum of 0. How? If I try to add all the elements, 5 minus 5 plus 2 minus 2. So it gives a sum of 0. Basically, I just have to return this. Subarray. So if I try the 0 based indexing, 0, 1, 2, 3, 4, 5, 6, 7. So what is my length of this subarray? That is 5 minus 2, that is the ending index, minus the starting index, plus 1. So 3 plus 1 is equal to 4. So 4 is my length of the array. 4 is the length of the array whose sum is 0. Okay, fine. So this is how zero sum array can be achieved. Zero sum sub array can be achieved. So there must be more than one sub array. That constitute a zero sum. Right? Because a sub array can have many sub arrays, right? And many sub arrays, there can be a possibility that more than one zero arrays are existing. That is, there can be more than one sub arrays in which the sum is equal to 0. Okay, so you just have to return the largest one. You just have to return the largest one. in which the sum is equal to 0. Okay, if I try to know about the brute force approach, suppose if I take this example only, 475 minus 5, 4, 7, 5 minus 5, 2 minus 2 and 3. Okay, let us consider this. So if I try the brute force solution, what can be the brute force solution? I can simply start from in every element. I can simply start from every element, and as I traverse, I can just sum. I can just sum, add the elements to my sum. Okay, add the elements to my sum, because suppose if I'm starting from here, I can just add this element to my sum. This becomes 4. I come to here, I'll add this to my sum. I come here, I'll add this to my sum. So I can do this for all the elements. I can do this for all the elements. Suppose for the first element, the maximum subarray that can be achieved is of this length. So all the elements would be traversed like this, and then this, and then this, then this, then this, then this, then this. Okay, so whenever my sum comes to zero, I can simply update my max value to be j minus I plus 1, and simply I'll compare it with max, the previous max value, and whosoever is the max, I'll just simply assign it to my mx variable. Okay, this is for my first index, and I can do this for all the indexes. So when I'll come to this index, and I'll start traversing like this, and when I'll come to this element, my sum will be 0. My sum will be 0, because we just saw that this sum is 0. 5 minus 5 plus 2 minus 2. So all the elements are cancelling out each other. So the sum would be 0. So net sum would be 0. So I'll be starting from this and ending to this element. So the sum would be 0. Okay, so basically this is not a good approach, because I am just computing all the subarrays, which is gonna take me a time of n square. Why? Because I'm just traversing the whole array for each element, and we are doing it for each element. So total n into n becomes a time complexity. Space complexity is constant. So what can be my optimal approach? Suppose I consider the same array. 4, 7, 5 minus 5, 2 minus 2, 3. 4, 7, 5 minus 5, 2 minus 2, 3. Okay, suppose this is my array. Okay, this is my array. So what I can say is I'll simply what can be the speciality of the zero based index array, like zero sum array? What is the speciality of this zero sum array? If I try to see that whole of this sum is 0, the net sum of this array is 0. Just remember that. Okay, net sum of this array is 0. What I say is I declare a sum variable. Okay, and I declare an unordered map. Why declaring an unordered map? Suppose I'm starting from this index, okay, and I'm adding it to my sum, and I'm adding it to my sum. Okay, so adding this to my sum value becomes plus 4. Okay, sum value becomes plus 4. So if I tell you that I will iterate each element, and when I come to this element, what my sum becomes? 4 plus 7 is equal to 11. 4 plus 7 is equal to 11, because I am calculating the sum till now. Okay, so till this index, now I know that my sum is 11. Now I know that my sum is 11. Okay, so if I tell you, if I ask you, okay, if I ask you, what is gonna be the sum at this index? What is gonna be the sum at this index? How can I tell? How can I tell? Why are you skipping all these elements? Why are you skipping all these elements? Just try to consider this, that I already told that the net sum of this is 0. So this array is not gonna be contributing to my sum, because anything plus 0 is the same number. Suppose a is my number and I'll add 0 to the number, my number remains the same. Okay, so if this array is existing, but the net sum is 0, so after that also, after traversing that whole array also, my sum would remain 0. My sum would remain the same as it was before traversing that array. Because if here my sum is 11, here also my sum is 11, because these elements have a net sum of 0, and x plus 0 is equal to x only, right? Is equal to x only, na? So what I can infer from this is, if suppose x, y, z are my initial elements, and these are my basic elements, these are some of my elements that have a net sum of 0. I am not considering what are the elements, and I have a element k here. Okay, I have an element k here, or at the last index, Okay, so what I can say is basically, and not here only, what I can say is, if these elements are summing up to 0, I'll just try to sum all these elements. My sum is currently x. I'll traverse to the second element, my sum is x plus y. I'll traverse to the third element, my sum is x plus y plus z. So before traversing this particular array, my sum was x plus y plus z. What will be my sum after traversing the array? My sum is gonna be the exact same number. Why? Why? Because anything plus 0 is equal to the same number. Okay, this is going to be the same number. This is not gonna add anything to my sum. If I have this array, suppose 5 0 0 0 3 2, okay, and if I try to add all the elements, I'll just simply make a map. Okay, I will make a map, but I'm trying to show you with the help of an array. Okay, so I'll consider there is my sum variable that will store the sum up to the current element, means including the current element also. So if I come here, sum was currently 0, sum was initially 0. I'll just add my first element, sum becomes 5. Okay, I'll come to the second element. What my sum becomes? 5 plus 0. It is the same. Right? Because this has a sum 0. This is not contributing anything. What if I come to the second index? What is gonna be my sum be like? 5 plus 0 is exactly the same number, right? So it is gonna be 5 only. Okay. If I come here, again 5 plus 0 is gonna be 5 only. So this was acting as my 0 array. Basically not acting. This is the 0 array in this case. Okay. So if I ask you what is the length, the longest length of the array, of the 0 array. Okay. So what you can say is, I'll just simply subtract this and this. Okay. I'll simply subtract this and this, because if this is my indexes, these are my indexes 0 1 2 3 4 5. And if I just simply subtract, if this is my range, and I want to get this array, so I will simply, if suppose this is my sum p and this is my sum y, and this is what I want to get, z. Okay, so y can be achieved by p minus z, p minus z. So I will just simply subtract, the third element, third index, and the zeroth index, because why I'm subtracting it, because the sum remains same. So this becomes a criteria, if I store them in a map, how would I know, how would I know that which element index to subtract from, which elements index to subtract from? Okay, so if I encounter, see, I'll take this example, 2 minus 2 3. Okay, so if I take this example, I'll try to do the same thing for this. I'll try to do the same thing. Sum is currently 0. I'll add the first element, sum becomes 4. 4 plus 7, 11. 11 plus 5, 16. 16 minus 5, 11. 11 plus 2, 13. 11 minus 13 minus 2, 11. 11 plus 3, 14. I'm just adding these elements and getting the sum. Okay, so how can I say, how can I identify at each element that what if there exists a zero sum array before this, we have considered a thing that sum plus 0 equal to sum itself. So if basically we are considering this as an array, if we are considering the zero sum as an array, so I can just store this sum in my map. And with the index, why? Because anytime in future, if I refer to this sum again, that means that sum minus the index that my previous sum was on. Because like, if I come to this element, suppose I'll do the dry run of this question, then you will understand. I'll do the dry run. Okay, so this is my map where I'm storing the sum as well as the index that is occurring on, okay. So if I do for 4, I want to check whether there is a sum that is already present in the array before. There is already a same sum that is present in the array before. Because if it is present in this array before, that means there exists a zero indexed array. Because as I am adding each of the elements, if there exists a zero indexed array, then only I can get the same value, right? Because anything is not gonna be giving me anything adding, like x plus 1 cannot give me x plus 2 cannot give me x, only x plus 0 can give me x. Okay, so if the sum is occurring again, that means that there is a zero indexed array, there exists a zero indexed array. Because if it had not been existing, then my x would not occur again. Okay, and where can I store that? If this sum has occurred before, yes, I can simply store it in a map. So for 4, I'll simply check this is my sum array. Okay, this is my sum array where I am storing all the sum. Basically, I will not be making a sum array. I'll just simply making a variable and storing. For your understanding, I'm just making an array out of it. Okay, we can do this like this also. Okay, so I can get to 4, and I can check in my map. I'll delete this. Okay, what I can infer is basically I will get to each of the sum where I will get to each of the sum, each of the numbers, each of the sum that I can make. I can get to 4. I can get to 4. I'll simply check it in a map. I'll simply check it in my map if the sum is occurring before. Because if the sum is occurring before, there must be some array. There must be some array that has a sum 0. There has to be an array that has a sum 0. That is why my sum is occurring again, right? That is why my sum is occurring again. Okay, so 4, if 4 comes again, I'll simply first check in a map. First check in my map. Does it exist in my map? No, my map is empty. So what I'll do is I'll simply attach the value. I'll simply attach the value with its index. Suppose these are the indexes that I'm writing. Okay, I'll simply attach the sum with its value. So sum and my index is 0. It is occurring at index 0. Okay, fine. I'll go to the second element. I'll go to the second element, this 11. 11. I'll check for 11, whether it is occurring in my map. Whether it is occurring in my map. Is 11 occurring in my map? No. No. Obviously no. Okay. So I'll store 11 with its index. 11 with its index. Okay. So if I store 11 with its index, here comes 1, here comes 11. Okay. It is also stored in my it is also stored in my map. There is no zero index array detected. There is no zero index array detected till now. I'll get to 16. I'll check my map. I'll check my map whether there exists a 16. No, there doesn't exist any 16. So I'll just simply store it at the second index. Now, now, when I come to this index, I get a sum of 11. My sum again becomes 11. And when I come to 11, I check the map. I check the map whether my value is existing already, or not. Yes, my value is existing in the map. My value is existing in the map. Okay, my value is existing in the map. So I can simply what I'll do is I can simply take this index. I can simply take this index 3 and I can extract the index that is in my map currently. That is in my map currently, and then subtract it. Just subtract it. So 3 minus 1 becomes 2. Is 2 the zero index array is 2 the length of the zero sum array? Is 2 the length of the zero sum array? If I see the original array, it was 5 and minus 5, and 5 minus 5 becomes 0. So I am doing it right. I am doing it right. How I am doing it right? Because I will just subtract this from this. Okay, this from this. I'll just subtract the first index array from the third index array. Okay, do I need to update this? Do I need to update this? No, no. Why no? Because if I update this with 2, if I update this with 2, sorry, 3, if I update this with 3, the next time I would get the same sum again. Suppose I'll get 11 again. If I'll get 11 again, 11 occurs in this case at index 5, and 5 minus 3 is 2. Whereas 2 is not my answer, right? 2 is not my answer. I have a better array. What is my better array? 5 minus 5, 2 minus 2. This whole is also summing up to 11, because as you can relate to this, that x plus 0 is also x plus 0 plus 0 is also x. It is not like that you have that it is contributing anything. No, no, you will have x again. If you have x again, that means there can be any number of zeros in between. So you will just capture the first occurrence of the sum. You will just capture the first occurrence of the sum. And where is my first 11 coming? At the first index. You can simply observe it. Okay, I'll just remove the extra things from there here. Okay, just remove the extra things. 11. Okay, okay. Coming back to the question, okay, so currently, what is my length? What is my length of the maximum array? What is my length of my maximum array? 2. My max contains 2. Okay, I'll simply come here. I'll simply come to the 13th. 13. Okay, I'll simply come to 13. Is 13 existing? Is 13 existing in my array? Is 13 existing in my map? No, no, not yet. Okay, so I'll store it in my map. I'll just simply store it in my map. Okay, I'll move forward. I will move forward. I'll come to this index. I'll come to this index, and what I get is a sum 11 again. Is a sum 11 again? Is the sum 11 occurring on a map? Yes, it is occurring at what index? 1. It was first occurring at first index. If I had updated the value, I would get a wrong answer. I would get a wrong answer. But as I am having the first index, I can now calculate the maximum length. I can now calculate the maximum length. So what I'll do is I'll do the same thing again. I'll simply extract this index, that is 5, and I will extract MPP and MPP of sum, that is basically 1. So 5 minus 1 equal to 4. So 4 is my maximum length. As you can see, 5 minus 2, 2 minus 2. So this is of length 4, and this was my answer. This was exactly what I was looking for. Okay. If I go forward, so if I get 14, 14 is not currently in the array, I'll get it as a sum. So this is how I get my answer. Okay, I'll try to do this with the test case that is given. 15 minus 2, 2. 15 minus 2, 2. Minus 8, 1. 7, 10, 23. Okay, this will be my sum array. Just be clear that I will not be using the sum array. I'm just showing you so that you can visualize. Okay, this is my map. This is what is my map gonna be look like. This is my map. What my map is storing? Sum as well as the index. So first I'll just store the sums. Okay, I'll start with 15. 15. Add in the current value. The sum becomes 13. Add in the current value, sum becomes 15. 13 plus 2, 15 minus 8, that becomes 7. 7 plus 1, 8. 8 plus 7 becomes 15. 15 plus 10 becomes 25. And this becomes 48. 48. Okay, I'm sorted for now. Okay, I'll start from the first index. Okay, I'll start from the first index. This is my first index. I come to here. I'll simply, what is my first step? Check in map. Check in the map if it exists. Okay, so I'll come to 15. I will check whether it is in the map. If it is not existing, then simply update. So 15 is not occurring in my map. I'll just simply mark it. What is the index? 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 15 comes with the index 0. 15 comes with the index 0. Okay, 15 comes at index 0. Okay, I have marked this in my sum. I come to the first index. What I'll do first is, I'll come to 13. And I'll check whether it is existing in my map. No, it is not existing in my map. I'll simply store it. As I see the sum first that is not occurring in my map, I'll simply store it. Okay, I'll move forward. I will I'll move to 15. I'll move to 15. Is 15 occurring in my map? Is 15 occurring in my map? Oh shit, yes, it is occurring. It is occurring here. Okay, so what I'll do is, if it is occurring, then I'll simply extract this index. I'll extract the current index, and I'll extract the index that is stored in my map. So 2 minus 0 becomes 2. So as of now, my maximum length is 2. My maximum length is 2. That is 2 is the maximum length that I have observed till now. Okay, I'll delete this. Remember, my max is 2. Okay, I come to this element 7. I come to this element 7. Is 7 existing in my map? Do I have to update this? Basically, do I have to update this by 2? No. Because if I update this, I'll get a wrong answer. Why? Because if I can get a longer array, why get the shorter one? Why get the shorter one? Okay, so this is my approach. Okay, I'll simply move to 7. Is 7 existing in my array? This is basically 1. Is 7 existing in my map? No, it is not existing. I'll simply update my map. So 7 comes at index 3. 7 comes at index 3. I move forward. I come at 8. Is 8 existing? Is 8 existing in my map? Is 8 existing in my map? No. I'll simply store it. Okay. I'll simply store it. Okay. I'll simply store it in my map. Now I'll come at 15. Okay. Now I'll come at 15. It's 15 existing in my map. It's 15 existing in my map. Is 15 existing? Yes, it is existing. So what I'll do is, I'll do the same thing. I'll extract the current index, and I will I'll extract the current index. I'll extract the current index. And what I'll do is, I'll just simply subtract it with the index that is present in my map. So it is what is present. 5 minus 0 is 5. So what my max value becomes, what I know is, I'll take the max of 2 and 5, so it becomes 5. Now 5 is the maximum array that I have got till now that has the sum 0. Because if I have got till here, that means this is the array that has the sum 0. So as I can see, minus 2, 2, minus 8, 1, 7. Minus 2 plus 2, 0. Minus 8 plus 1, 7 is equal to 0. So I am getting the correct answer. But still, I'll move forward to check whether there is any longer array with sum 0. I'll move forward. I'll go to 25. Is 25 existing in my map? No, 25 is not existing in my map. I'll simply store it with the index. I'll come to 48. Is 48 existing in my map? No, 48 is not existing. I'll simply store it. So as I have ended with my iteration, what I got as the max element is as 5. And what is the current value? What is the value of the array? What is the array that is giving me the answer? Minus 2, 2, minus 8, 1, 7. So this was the solution. The solution is basically based on the approach of any number plus 0 is equal to the same number. Okay, so this zero can be any array. Okay, and there can be multiple zeros also, right? Because x plus 0 plus 0 plus 0 gives me the same sum, that is x. Okay, and now I'm using an unordered map. So if I try to write the code for this, I'll try to write the code for this. What I first need is I'll need a max element that will be 0. Why 0? Because at max, because the lowest value of the array that I can get is 0. Minus array cannot be existing, right? I'll make an unordered map with int and int. Okay, I'll name it by mpp. I'll make a sum 0. Remember, I'm not using an extra array to denote the sum. I'm basically changing these values, and these are the values that the sum variable is gonna take. Okay, I'll just move from 0 to n, and for every element I'll include the current element. So to include the current element, I'll first sum it. Okay, I'll first include it in my sum. Now, if my sum is equal to 0, if my sum is equal to 0, basically for this case 5 minus 5, 2 minus 2. If this is my array, I start from 5, 0, then 2, then 0. So what is the maximum element in this case? What is the maximum element in maximum array in this case? This is the array. This is the array. So this can contribute to my maximum sum. This can contribute to my maximum sum, right? This can contribute to my maximum sum. So I'll simply make a condition for this, that if I get this, I'll simply return +1. I +1. Why +1? Because we are following a zero-based indexing. So I'll simply +1 the current answer. If my current sum is already in the map, what I'll do is I'll try to get this value, right? This is what I did in the whole try run, right? I got the current value. And I subtracted it with the value that was present in my map, and I'm taking the max of it. And if we don't update this, because if we don't find it, that means it is getting stored for the first time. MPP of sum equal to index. What I'm doing here is basically storing sum with its index. Okay. At last, I'll return mx. Why mx? Because it is storing the length. I ran it. Let's see if it goes fine. Yes, I'll try to submit. Okay. Okay, I'll add a condition that it should be max of mx and this. Okay, and again try to submit. Yeah. Okay. Because there can be a condition that like this is getting a 0, right? This is getting a 0, right? So if I simply return 3 in this case, this would be ignored. So I will be taking the max of all. If I go through the code again, I'm basically declaring an ordered map, declaring the sum, adding the sum to the current value. And if my sum becomes 0, that is all the elements are included, I'll take the maximum of I+1 and the current maximum that I have. Okay. If it exists in my map, just extract the current index and extract the index that was in the map, and basically subtract them and get the max value. If it is not in the map, that is, it is being stored for the first time, then simply store it. So this was my overall solution. What is the time complexity of this solution? As you can see, I am only traversing from one time. I am only traversing for one time. Okay. So the time complexity becomes O of n. Time complexity becomes O of n. And what is my space complexity? My space complexity, as I'm using an unordered map, so at max my space complexity can be O of n. At max, my space complexity can be O of n. So this was all about the solution of the question largest subarray with zero sum. Okay, I've discussed about the brute force approach. By just you can just calculate all the subarray sums, and you can just compare the all the length of the sum with sum zero, length of the subarrays with sum zero. Okay, and you can return it. And if in this case you can basically make an unordered map. You can basically make an unordered map. You can basically make an unordered map and return the maximum length out of these. Return the maximum length. Okay. So this was all about this question. If you have any doubts, just ping it down in the comments. Just ping it down in the comments. And if you like the solution, just do share, like, and subscribe. Okay, I'll keep making these videos like solution. If you liked it, just comment it. And if you want any particular solution video to be made by me, just comment it down with the link of the question, or just a name, or any type of hint you want to give. Okay, you can give any question. Okay, so I hope you enjoyed the video. Like, share, subscribe. Thank you. Have a nice day. Bye bye.